Hello and welcome to a new series in ordinary differential equations. Since we have understood the basics of ordinary differential equations, we're going to be looking at analytical methods of solving differential equations, part 1. And for part 1, we're going to be considering all about first order differential equations. I hope we still understand what the order of differential equations are. First order differential equation is just a differential equation where the depth of differentiation is just 1. So that's a first order differential equation. The depth of differentiation is just 1. So you're just going to be seeing y prime alone in that differential equation, or dy dx, or dy dt, and so on and so forth. So many engineering systems usually deal with a lot of differential equations, and thankfully there are several analytical methods to solve these differential equations. So we're going to be looking at separable variable differential equations and how to separate variables and solve differential equations. And we have linear first order differential equations. Okay, we're going to learn about linear first order differential equations. I'm going to be introduced to something called integration factor. Then we'll learn Bernoulli differential equations, which is basically an extension of linear first order differential equations. And we'll learn about homogeneous differential equations and how to solve them. Then exact differential equations, one of my favorites. So another thing that you'll be introduced to is initial value problem. So IVP, just like I said, is the acronym for initial value problem. So let's look at what Wikipedia says about IVP. In multivariable calculus, IVP is an ordinary differential equation together with an initial condition which specifies the value of the unknown function at a given point in the domain. It is permitted for now that you do not understand what this means, but as we go further into solving differential equations with the various analytical methods, we are going to stumble upon solutions to differential equations where we come up with constants. And how do we find those constants? We need to know some initial values in order to substitute into the function. Then we determine constant values. So just know that for now, when we talk about IVP in ordinary differential equations, we want to solve a differential equations where some initial condition is given. Okay, a differential equation plus some initial condition. So for first order differential equations, you're just going to be having only one initial condition, and so on and so forth. Then for second order differential equations, when we get there, we'll be having about 2 initial conditions to be able to determine all the unknowns in the function. So thanks for watching this video. I hope you stay tuned, and next class we're going to be diving into variable separable differential equations, or separable variable, however you want to see it. Thank you very much. See you. Like, subscribe, and hit the notification, share to your friends, and thank you. Bye.